Hi. Well, we're going to start chapter 6. We're going to do 4 sections in chapter 6. And in some ways, we're coming back to fractions, but it's not that we're going to be uh, adding and subtracting them or anything like that, but we are going to be dealing with some fractions here. And these fractions are going to be called a ratio. So a ratio is a fraction, and it relates two items together. So it's almost like you're comparing two items. And I guess really don't make it harder than it is. So let's go through a few examples. Find fraction notation for each ratio. Where they're telling you to find the ratio and fraction notation, which means there may be other notations that you can express a ratio as. We'll do what they want, and then I'll show you some of the other notation they may want later on. So they want find fraction notation for each ratio. Do not simplify. So again, make sure you pay attention to words like that. So here, 8 to 9. As a ratio, we would write it 8 to 9. So ratios can be written as fractions. They do not want you to reduce this, and you couldn't anyways, so you're done. So that's the fraction notation for the ratio 8 to 9. The number you come across first always is in the numerator. After the 2 goes in the denominator. So that, because order does matter. Now, I told you there's other notations that they're not asking for right now, but I wanted you to be familiar with it. You can also write it like this. With this colon mark, that means this is red 8 to 9. So these all mean the same thing. Okay, in this case, they wanted 8 to 9 as an answer as far as a fraction. So, but just be aware that it can be written like this. Every once in a while, I'll throw that in just to kind of remind you. All right, now this one right here, 621 to 758. So we're just learning how to write them. In section 6.3 and 6.4, we'll be applying them into some story problems, but now we're just learning to write them. That's it. That's your answer. Because we don't need to simplify. I don't know if you could or not. Well, let's go on to the next one. Okay, here, 0.3 to 7.1. That's it. Then I want you to simplify, you're done. Okay, let's just do maybe, well, let's do 8 and 9 here. 62.9 to 74.2. Again, pay attention to the order. Which one goes in the numerator? Which one goes in the denominator? The first number, numerator, second denominator. All right, now if you have these fractions, it's just going to be a pain to type into MyMathLab because you have to use that template. There's your first number. We're not simplifying these, so we'll just leave it like that. That's it. That's your answer. 12 3/5, 2, 4 1/2. All right, so we're comparing them as a fraction. Okay, and this one here, we may as well do them all. Over 13 4/5. Okay, so this is because they told us not to simplify. We're on the in this section we'll be doing some simplifying. All right, so then here is a slide application, and we'll look at some other ones here. Well, not necessarily an application. Well, yeah, it is an application of writing ratios, but there's no solving yet till we get to sections 3 and 4. One of the most active hurricane seasons in recent history was 2005 with 28 named storms. One of the least active hurricane season was 2013 with 13 named storms. What is the ratio? So when they say what is the ratio, we'll be writing a fraction of storms in 2005 to 2013. So order matters. And so because you came to this first in the reading, the 2005 storms will go in the numerator, which would be 28. 2, the storms in 2013, which is 13. It doesn't say to simplify, which you couldn't, because nothing goes into 28 and 13. So you would leave it like that. That's your answer. Now, you know, if it was ever multiple choice, they may have this as a multiple choice. It means the same thing. Notice the 28 comes first, and then you have 2. This would be read 2, 28 to 13. So that's another way of writing a ratio. Okay, I have another one I'd like for you to look at. It might look a little confusing, but I'll just try to walk you through it just because of the way they write it out. Okay, we're going to ignore this one right here for right now. Jackie's dog had a litter of 3 male puppies and 4 female puppies. What is the ratio? We'll be writing a fraction of the male puppies to the female puppies. So because we come to this first, we'll put the number of male puppies, which is 3, to the number of female puppies, which is next, which is 4. Okay, so the answer is 3 to 4, and they may write it like that. Means the same thing. Okay, let's look at another one. I mean, it's the same type of problem. It's just dealing with that same. We're not to that one yet, so I'm just going to cover it up. Okay, let's look at what is the ratio of female puppies to the total litter. So they want the female puppies to the total. But we weren't given the total. We were given the number of males and the number of females. So we want the female puppies, that came first in our sentence, which is 4, over the total. Well, it's not hard. You're going to have to find the total by adding the 3 and the 4 together. 7. So just be aware that, you know, even though they give you these 2 numbers, sometimes you may have to add them together if they do want the total. So just be aware, just pay attention to it's the female to, if it's the total and you're not given the total, you'll have to find the total. And we find the total by adding. Or if there's a bunch of them, you can use multiplication, because multiplication is fast adding. All right, let's look at another one kind of along this line right here. For a company picnic, 46 people ordered the pulled pork sandwich meal. 35 people ordered the grilled chicken sandwich meal. What is the ratio, fraction, of pulled pork sandwiches to the grilled chicken sandwiches ordered? So we'll find the pulled pork, and in this case, they tell it, we don't have to subtract or add or anything. 46 over the grilled chicken sandwich, 35. All right, and then you're done. Now here we have another question. How about of the grilled chicken sandwich orders to the total orders? So we've got the grilled chicken to the total orders for this next question. The grilled chicken is 35. The total is 81. I got 81 by taking 46 plus 35. And you get 81. So we had to add them to find the total in order to find the ratio they wanted us to have. Okay, great. Let's move on to our next section. No, sorry, not next section. We're still on 6.1. I wanted to do one more page of 6.1. Pretty much on the same lines that we just did. Walmart donated $5 million for the relief efforts in Puerto Rico after Hurricane Maria. Microsoft donated $5.2 million. What is the ratio, make a fraction, of the amount of money donated by Microsoft to the amount of money donated by Walmart? So we're going to put Microsoft came first before the 2. So we're going to put Microsoft in the numerator, 5.2 million, 5.2, to the amount of money donated by Walmart, which would be 5 million. Okay, and there's your answer, 5.2 to 5. You could write it as 5.2 to 5. So there's our writing ratios. Let's look at some examples where when we read the instructions, it tells us find the ratio of the first number to the second, which we're going to do, and then simplify. So we have to, in other words, when they say simplify, you need to reduce the fraction you've created. Well, here we're going to find the ratio of the first number to the second number. So 6 to 8, and then we're going to reduce it. Divide them both by 2. So we get 3 to 4. Divide by 2. And you can't, there's nothing else that will go into those. So your answer is 3 to 4. 3/4 or 3 to 4. Let's look at the next one, the first number to the second number. And then you reduce it because they want you to simplify the ratio. And eventually we're going to be going backwards. You know, go from the 3 to the 6 and the 4 to the 8. Those are some applications of the ratios. But here we've got, we can reduce it down. We can divide by 6. Let me get rid of that equal sign. So then we end up with 2 over 3 or 2 to 3. Either one. They'll let you know if they want a fraction or if they want it written like this. They'll tell you. Let's do another one. These aren't so bad, especially if you know your multiplication tables pretty well. It looks like I'm going to divide by 7. Okay. So let's see, 56 divided by 7 is 8. 63 divided by 7 is 9. Or you could write it as 8 to 9, either way. Okay, let's look at maybe something a little bit harder. Let's do some with some decimals in them. All right, let's do 16 and 17. Whoa. Okay, we're going to put 6.2 over 10. Okay, now to reduce this, I would get rid of the decimal, move it over once, move it over once. So in other words, multiply by 10 over 10. So we end up with 62 over 100. All right, so if you move this over once, move that over once. You just have to add a 0 there to move it over once. And now you can just start to reduce it. You can say, okay, well, they're both even. So I'm just going to divide them by 2. And then I'll see. Well, 62 divided by 2 is 31. 100 divided by 2 is 50. Looks like maybe that's it. All right, because can't divide them by 2 because 31. Can't divide it by 3 because I add up to 4 and 3 doesn't go into 4. So then we're done. Okay, let's do another one. Let's do 17. 5.2 over 6.8. I'll get rid of the decimal. If you move this one once, you have to move this one once. And it worked out great. Okay, so that means you've got 52 over 68. And reduce it. Well, let's just divide by 2 because I'm not really sure. Maybe 4 probably would have gone in both of them. Yeah. Oh, well. So we'll just divide by 2, even though 4 would have gone into them. So let's see, it goes into there 40, 20, let's see, 2 goes into 5, 43, no, 46, okay. No, it can't be 46. It's got to be 26, sorry. Okay, 26, 52 divided by 2 is 26, and then 68 is 34. Oh, they're both still even. So divide by 2. So you get 13 and you get 17. Now you're done, 13 to 17. So you're just reducing fractions. Like in this one, divide by 2 until you can't reduce it anymore. Okay. All right. So hopefully, you know, that kind of straightens up how to reduce those. I'm going to look at 19. Now I'm going to do one more decimal. I'm leaving out that 0 in between because I'm going to get rid of that decimal. Here I have to multiply by, I have to move the decimal twice. And I'll move this decimal twice. So you get 36 over 48. And then you can reduce it down. All right, by dividing them by 2 or 4. I divide them by 4. Yeah. No, I divide them by, well, sorry, you can divide by 6 too. Divide them both by 6. And 12. Divide them both by 12. That's, yeah, 36 divided by 12 is 3. 48 divided by 12 is 4. So divide them both by 12. Or you could divide them by 2 and then divide them by 2. And then just keep dividing until you can't find something that goes into them evenly. All righty, that's 6.1. That's not too bad, I don't think. Now let's look at 6.2 or 6.1. Let's look at 6.2 now. 6.1 is done. Move it over, straighten it out. Okay, what we're going to do now is we're going to find, let's see, oh good, we can round to the nearest hundredth. Find each rate or speed as a ratio of distance to time. So when we find a rate or a speed, the units really tell you what to do here. And it is a ratio, you know, rate is usually distance over time is what we have for speed, is distance over time. So they want distance to the time. So we're going to put distance over the time in order to find the rate. So we're going to have 520 miles over 8 hours. Another way to think about this is when you find the speed or how fast you're going, you always say like miles per hour. Remember that per means divide in mathematics. So you're taking the miles divided by the hours. So the units kind of give it away as well as to what you're doing with this ratio and which one goes in the numerator and which one in the denominator. Okay, they do want us to divide this out and round to the nearest hundredth. Okay, so let's go ahead and take 520 divided by 8. Oh, we don't have to round because it's 65 and they'll have the units there for you. It might be a drop down box for the units, miles per hour. Okay, let's look at number 6. We take the distance, 68.6 meters over 7 seconds. 68.6 divided by 7. No, 9.8 meters per second. So you're kind of keeping those units as the ratio. The units keep that ratio of distance over time, miles per hour and meters per second. So I'm hoping you've got that. You know, this one, take this 7, take 321 divided by 7 and get kilometers per hour. That's all right. We'll just finish it over 7 hours. So we get 321 divided by 7. Oh, well, I'm glad we did this one because this is one we're going to have to round. So if you look here, when I took 321 divided by 7, I got this. Well, they want us to round to the nearest hundredth. The 5 is in the hundredth spot, tenths, hundredths. So that 5 is going to become a 6 because that next number is 5 or bigger. That 7 is going to make that 5 a 6. So we're going to have 45.86. Kilometers per hour. So we're saying per instead of like the ratio. All right, that's how you find rates. You guys probably knew that even before. Good. All right, let's look at number 8. I'm just kind of looking at some more of a story type problem, trying to get them set up, and then we'll look at solving them in the next section. Population density of Alaska. Alaska has a population of 731,449 people and an area of, I thought it was bigger than that. Well, it's square miles, sorry. Yeah, it is. 570,640.95 square miles. Well, that's quite a bit. What is Alaska's population density? So density is also a rate, it's a ratio. Density, in your chemistry class, the density is the mass per unit volume. So you'll have units like grams per cubic centimeter or kilograms per cubic meter, that kind of a thing. But our density is going to be the rate of people per square mile. Alaska has the lowest population density of all 50 states. Well, I guess we're probably pretty close to Alaska. So we have people per square mile. So the number of people will go in the numerator. Okay, per divide square mile. .95. All right, so what do we got here? 731,449 divided by 570,640.95. So roughly 1.28 people per, I round off to the nearest hundredth, per square mile. Per square mile. All right, I should look and see what Wyoming's is. But that's Alaska, 1.28 people per square mile. Great. Let's look at some other examples of this idea and then apply it to some money. But I want to do number 9, and then we'll look at 10 and 11, and we'll be done with this with 6.1 and 6.2. All right, natural gas usage. William's gas bill for the month of February showed that he used 175 therms in 28 days. What was the rate in therms per day? So per would be like the therms today. So this is per is our divide. So we're going to create a ratio. The therms, numerator, 175. Days, 28 days. We're going to divide them. 6.25 therms. I guess I need an R in there. Per day. And there's your rate, you know, which is a ratio, and we're making it into a decimal, but yeah. Okay, perfect. So this is not so hard. This section shouldn't give you guys too much trouble, but we'll see. Let's look at the next one. Find each unit price in cents per ounce. Okay, so they want this ratio, this rate. They want cents per ounce. So you're going to take the number of cents and divided by the number of ounces. And the reason we do this is so you can compare. They also want us to round to the nearest thousandth, which we'll do. And then we'll see which one is the cheapest. So we're going to find the cost, the cents, okay? And they want cents. So we'll deal with that later. We'll make sure that we have cents and not dollars. But we're going to take $2.50 divided by the number of ounces, because that's what we want, the cents per ounce. Now you can change that to cents right now since we want our answer in cents. So you move the decimal over twice. $2.50 is 250 pennies. Each of those dollars is 100. So to go from dollars to cents, you move the decimal to the right twice. That's our cents. I'll put it behind it. Cents per ounce. So we take 250, divided by 14.5. We're going to get 17.241. Now they want us to round to the nearest thousandth, tenths, hundredths, thousandths. So that one is in the thousandth spot. So we look to the right and we increase it by 1. So we get 17.241 cents per ounce. Okay. So I did change, and it does, it's easier, I suppose, if you do change that to cents, because that's what they want the units in. Okay, let's look at this next one. Okay, we have, the same object. They don't tell us what it is, but it's almost $4 for 18 ounces. So let's find out how much it costs per ounce. We move the decimal over twice to make it pennies. So how many cents we've got over 18. And so we take $3.99 divided by 18. We get 22 point, and this is 166. Okay. Tenths, hundreds, thousandths. We look to the right, so we're going to increase that one to a 7. And this would be cents per ounce. All right. So which one's cheaper? Okay, well here, let me write it here. So we have got 17.241, and we have 22.167 cents per ounce. Well, and sometimes they'll ask you which one is cheaper. Oh, yeah, they do. Determine which size is the better buy based on the unit price alone. Well, the better buy is this one right here. So this is cheaper. To buy this one, $2.50 for 14.5 ounces rather than buying this one. So to compare items in a store, you take the amount of money divided by the ounces or the pounds or whatever. Okay. All right, let's do baked Tostitos and be done with this video. Same idea. Well, oh, I see. They did tell us what it was, you guys. It was a Post Honey Bunches of Oats cereal. We were comparing cereal. I don't know why I didn't notice that. Okay, but now we're going to do baked Tostitos, which is the better buy. So we'll take $3.29. That's how many cents here over 6.25 ounces. 329 divided by 6.25. We're going to get 52.64 cents per ounce. Okay, and then we'll do the same thing with the 9 ounce. Okay, so one other thing here. We're supposed to go to the thousandth because it stopped, I forgot. Tenths, hundreds, the thousandths is a 0 because the calculator didn't give us the thousandths. So it just gave us 52.4 when I divided those, but they want us to go to a thousandth. So MyMathLab is going to want that thousandth place. So you put a 0 there. Cents per ounce. Okay, let's do our next one. It's $3 for the Tostitos. It's, oh, interesting. $3.99 or 399 pennies. Always move it to the right twice to make it pennies, divided by 9 ounces. So 399 divided by 9. We have 44.33333. So we're going to go to the thousandths, tenths, hundreds, thousandths. Look to the right. It's less than 5. So we're going to leave the 3 alone. Those other ones go. So we've got 52.640 cents per ounce. And we have 44.333 cents per ounce. All right, which one would you like? Which one would be cheaper to buy now that you have the total price? Here, the price per ounce, this one is cheaper per ounce than this one is. So you're better off buying this one. So you always take the money divided by the ounces. Unless they're both in pounds, you can divide by pounds. Okay, all right. Well, that actually does it for 6.1 and 6.2. So I'm hoping that those don't take you very long. And we have got one more video to go for this chapter. And then after this, we'll start doing just one chapter at a time, or not as many topics, because we're going to do percentages. And it gives people it can give people some issues. So I wanted to make sure we just did that alone. All right, let me know if you have questions. Bye-bye.